Maybe I could do this.
I think we could do this in one shot.
I also might have said one shot. I don't know, it's 11 o'clock.
I've been really wanting to play around with this. I've had the kit for a couple of days. And I really want to solder this together and want to solder this derbitor.
But I'm pretty drunk. Yeah, accurate statements. And I want to do a video about this, but as much as I would enjoy the fuck out of soldering this hammered, yeah, I think I might want to wait till tomorrow.
Two-man here. So instead of doing drunk soldering last night as intended, we're doing hungover soldering the next morning. Anyways, this video is going to go over the Arduinoboy. That's going to give me control over the Game Boy using MIDI. It will work with LSDJ, and there's another little synth cart program thing that I have, which has a little bit more direct access to the synthesizers inside of it. So we've got from Catskill Electronics the PCB itself. On this, I'm going to show you how to read where all of the parts go. I'm going to explain what all of them do. We've got resistors, diodes, LEDs, little microchip guy that I'm going to explain a bit more about how that works, and the Arduino Uno. These are microcontrollers. People can build RC cars with them. There's a lot of cool things. I have some LCD screen eyes that I'm working on for a project that uses a teensy, little tiny version of it. So, fuck, here we go. The first thing that I'm going to work on is the resistors. They're the most simple to install, they're non-directional, but a really important thing I want to cover is how to identify what resistor you have. On the PCB that I got, it actually tells me how many ohms of resistance each one's supposed to be, and online I have my official instructions that identify them, but unfortunately this is for an older revision. One of the resistors is missing. These codes are for a 4-band code, these are 5-band, so those don't do me any fucking good. So you can hop online, there's a lot of apps that are really cool that you can put in as a calculator and it'll tell you what bands are supposed to have. You can even like the ones that I need are a 220 ohm resistor. You Google that and pull up a picture of which one it's supposed to be and help identify it. These are really easy to put in, and we're going to get started, and I'm going to show you how to solder stuff in, not get cold solders and do it correctly. The point of soldering is to heat up the components and not just melt the solder. So we're going to get this thing flipped over, I'm going to get it bent into shape, soldering iron's preheated, and the fun's going to start now.
Alright, so we're ready to start putting in our resistors. These are all going to sit here, and as you can see, they're all marked with a resistance. I've already looked them up, I have them sorted out. But we're going to start with the first 220 resistor. Going to have to take this guy and bend the legs over. So it's going to fit through the hole. And remember, these are non-directional, they don't care. I'm going to put it through. It's in place. Flip your board over. And we're going to bend these outward. I've been told that NASA standards require it to be at a 45-degree angle, but I don't have a tiny enough protractor, so I'm not going to fucking worry about it. Again, I'm going to emphasize this, that you're not just trying to melt the solder and get it to land on the board. The important thing is you want to hold it, get the solder pad and the component hot enough to melt the solder, and then when you pull away, you should have a decent solder point. So after you make your solder, you're now going to take some angle cutters. These are really flush. They're only beveled on one side, so you can get as close as possible. Now, you don't need to get completely down on the PCB. I usually go right above the bubble. and we're going to cut the excess off. And that's our first component.
So with our first component in, I mean, it would take a really long time to put each individual piece in, bend the legs over, flip it over. So to speed things up a bit, what we're going to do is we're going to add the rest of the resistors and just solder them all in at the same time.
Now, I typically do only a few at a time, whether it's all the same component or in a certain area. You don't want to build the whole board up because that would be a little overwhelming.
And there we go. We're done with the resistors.
So real quick, we're going to solder the button in. This is a little momentary button. There's also things called momentary switches. They are either identified as normally open, normally closed, so that means in its rested position, just sitting there, that is a normally open circuit. If we close it, it completes the circuit. So this little guy actually only fits in these holes one direction. The legs do make a difference because when you press it down, it completes a circuit from here to here and here to here. This guy already has a little couple of bends in it. It'll hold itself in place.
We've got that in. The next thing we're going to do is put in the diode and the light emitting diode. A diode has a cathode and an anode, and it works like a one-way valve for like water. It only allows electricity to flow one direction and prevents, like if you plug something in backwards, from it burning a circuit out. It adds protection. So down here on our PCB,
this little signature means that's where the diode goes, and we've got this line across it. And on a regular diode, might be kind of hard to see, see if we can get that up in there. There's a little tiny line on it. That line corresponds with the other. I'm gonna take this guy. I'm going to fold him through. Now these guys, because they control direction of flow, it does matter which way they go in. So that's an important thing to take care of. Same with a light emitting diode or an LED. The only difference is those, when powered, will actually light up. Those were developed somewhere in the 1970s, used mostly on computer boards to identify trouble codes, other things. The original Game Boy, its LED is a very early style and does not put out much light, whereas modern LEDs are extremely fucking bright. So one thing to take note on an LED is you've got one long leg, one short leg. The long leg is your positive, this is the ground or negative. On our PCB, you can see it, well, either side really. This side is actually a little bit easier to identify if we get up close here. You'll notice that this hole is round. This one has a square around it. The square usually identifies ground or negative, and you know, if you look on this side where the ground's at, I mean, these all share this large common space, whereas otherwise there's a leg going to each of those. So what we're going to do is the long side goes through the positive, short through the negative. Put all of these in. we've almost got the sync port for the Game Boy installed, but one thing that I wanted to point out is solder points are not always just about connections, power, data. On these bigger ones here, these guys require more solder, and they're actually structural, because this port is something that's going to be plugged and unplugged a lot. It needs something to help hold it in place, but it also acts as the outside ground, so it's a dual purpose thing. So anytime you have something that you're trying to solder in or desolder, these are the things that are really doing most of the work holding it into place. I've got most of the other components installed. One of the things I wanted to go over is this little chip here. We'll get a close-up of it later, but there's actually some letters on it. It's a 6N138. Anytime you have a chip like this, you can put it into Google. It'll tell you what it is, what it does, and you can usually get a pinout. This is extremely helpful when you start getting into the more advanced things. This little guy, that was really fucking neat. I didn't know that this is how these worked. I guess this 6N138 is very common in MIDI devices, and it allows circuits to talk to each other without giving any voltage interference. The way that it works is, I want to tear one of these apart and actually fucking see this for myself, but I guess there's a small light source and a light reactive resistor on the other side of it, and that's the way that it's able to give signals without any voltage interference. And Look Mum No Computer actually makes one of these things in his video for the Red Bull can. That's a synthesizer. He controls it with 18 volts, a transistor. He cuts the middle leg off and builds this cool little thing, but it uses essentially kind of what's going on in here. So, getting back to putting these things in place, if you look on the board, we have a designation for that 6N138, but then you can also see this little notch cutout. And what we have here is a socket that it fits into. It has the same notch, goes in the same direction. So, it's provided, I'm going to give it. I've actually mocked it up, and this guy does fit in the same holes. My guess is because of the sensitivity of the components inside, you don't want to get it too hot with soldering. The other thing is on larger chips, I'm sure that they have these sockets and they're replaceable because service reasons. So once you have that in place, you got to know which direction to put this. Well, we have a tiny little circle in the right hand corner here, and that matches up with the same spots. So once we get it soldered in, this little guy will just plug right in and it's good to go. So the last thing to solder in is the little jumper pins for the I/O input output. These come in a strip. They actually break apart really easily, so I need to make one more, and all you do is you line them up, twist it apart, and it fits in the hole. So these work on a very standard spacing. I mean, these will even plug into the breadboard. There's a lot of stuff when you start digging deeper into electronics that is just really fucking standardized. So the thing that I'm going to do to make sure that everything comes out nice and even and straight, because these go on the underside, is I'm actually going to plug, make sure that's the right one, these guys into the Arduino. Make sure this is the right one. Move this guy over, we're gonna have a bad day. Everything will line up and fit. Now doing this is going to make sure that everything stays nice and straight and even. If we ever have to disconnect, we can pull it straight out. So on each one, I'm going to start with a couple of solder points just to hold them in place. Again, the goal here is to heat up the components hot enough to melt the solder, not to try to melt the solder with the soldering iron to the components. if the things you're soldering are not hot enough to melt the solder themselves, it doesn't flow correctly. You get weak solder joints. So another thing I wanted to point out is the thing I've been using recently is this copper cleaning pad. Traditionally, things will come with a moist sponge, and this works really good for cleaning too. But the advantage of this is it cleans the tip off, but no water touches it, so it doesn't cool down your soldering iron, and you can keep moving faster. Alright, cool. So I finally got everything up and running. It actually took me a while to get this to work. Turns out that the sync port that was included with the kit isn't an exact replica of the one for a Game Boy Color. Luckily, I had a dead one that I was able to pull the port from, and it soldered actually right into place. I'm still having some other little finicky issues with it, but for the moment it's working. So I've got that going. The Game Boy is actually synced up to the beat step. The Sega Genesis is actually hooked up to the TR-08. And for the moment, yeah, I have everything actually talking and working. So that's just purely 8-bit Game Boy. So cool, there it is. There's Game Boy working over MIDI. The little project actually works. We've got Sega working over it, and just a few more things. This is really gonna be fucking great when it's done. So really appreciate you watching the video, and remember, if the two-man can, then you can too. That was terrible.
Dude. We did some cleaning. I feel like every time I even go, I do this outside of normal life. Not the stuttering, but the like, so here's a thing that I know of a thing about a thing. And my whole life has become a how-to video.